My name is Asu Özdaglar. I'm the head of MIT's Department of Electrical Engineering and Computer Science, and also a co-chair for today's event. It's my distinct pleasure to introduce our next speaker, President Maria Klawe. Maria Klawe is a renowned computer scientist, mathematician, and scholar. She became the 5th president of Harvey Mudd College in 2006, and she's the first woman to lead the college. Previously, she served as Dean of Engineering and Professor of Computer Science at Princeton University. She joined Princeton from University of British Columbia, where she served in various roles from 1988 to 2002. Earlier, she spent 8 years with IBM Research in California and 2 years at University of Toronto. She earned a bachelor's degree and a PhD, both in mathematics, from University of Alberta. She has made significant research contributions in several areas of computer science and mathematics, including functional analysis, discrete mathematics, theoretical computer science, and human and computer interaction. President Klawe is a renowned lecturer and has spoken widely about diversity in science, technology, engineering, and mathematics, about gender and gaming, and about lessons from her own career in STEM industry and education. In recent years, she has devoted particular attention to improving K-12 science and mathematics education. President Klawe is a board member of the nonprofit Math for America, chair of the board of the nonprofit organization edreports.org, a fellow of the American Academy of Arts and Sciences, a trustee for the Mathematical Sciences Research Institute at Berkeley, and a member of the Canada Excellence Research Chairs Selection Board. She has won numerous awards. I'm just going to say a couple of them. She's the recipient of the 2014 Women of Vision AB Award for Leadership from the Anita Borg Institute and was ranked 17th on Fortune's 2014 list of the world's 50 greatest leaders. In 2015, she was honored with the Lifetime Achievement Award from the Canadian Association of Computer Science and the Achievement Award from the American Association of University Women, and she was inducted into the U.S. News STEM Solutions Leadership Hall of Fame. She was honored by the CRA's 2016 Distinguished Service Award. We're delighted that President Klawe is here to share her unique insights in this historic symposium. In fact, the title of her talk beautifully sums up our overarching theme for the day: computing is for everyone. So please join me in welcoming President Klawe.
So first of all, it's a thrill to be here. I am incredibly excited about the fact that MIT is starting the Schwarzman College of Computing. I think there are huge opportunities for certainly all educational institutions in the United States and elsewhere around the world. And particularly as president of Harvey Mudd College, it's really nice to be here to talk to you about computing is for everyone. So the first thing I will say is one of my, I'm old, I am 67 at this point, and so I'm of an age that when I was growing up, anyone else my age here? I know I have a bunch of friends here. Thank you. I'm of an age that, when I was growing up, people said to me all the time, girls aren't good at math. And it was just like what everyone said. And I loved math. I loved other things as well, art, English, all areas of science. But I particularly loved math. And when I started as an honors math major at the University of Alberta, my professors would say to me, Maria, we just don't understand why you want to be a mathematician. There are no good female mathematicians. Now, they knew and I knew that I was one of the top 2 students, math students they had had in a decade. So they were not telling me that I wasn't good at math. What they were saying was, you are good at so many other things as well. Why would you pick math when you're going to face all of this bias throughout your career? Now, I happen to be extraordinarily stubborn. Everyone in my family knows that if you want to get Maria to do anything, you tell her she shouldn't do it. My kids especially have used this against me many times. So I think one of the consequences of feeling that way is that from very early on, I was absolutely determined that women should be as welcome and as supported in math and all the other areas of science and engineering where they are not well represented. And growing up in Canada, I was much less aware of issues around race, just because it's a different country, it has a different culture. This is not to say that we don't have racial discrimination, we certainly do, particularly around First Nations, Aboriginal peoples. But it's just not the same kind of issue that it is in the US. And so when I moved to Princeton as Dean of Engineering at the beginning of 2003, all of a sudden I was sort of like, oh yeah, gender's really important, but oh my goodness, the question of underrepresentation is really more important for Black people and Latinx people and Native Americans and so on. So I have spent most of my life as an adult. Yes, I love math and theoretical computer science. I love doing research and I love teaching. But my passion is to really change the culture of science and engineering so that we support everybody who brings ability and passion and hard work. And when I moved from Princeton to Harvey Mudd College, I remember Shirley Tillman, who was the president of Princeton, saying, how can you do that? You're supposed to go be president at Yale or Michigan or MIT or something. And I said, well, actually, for what I care about, I think how we influence education, the culture that we demonstrate in how we educate our undergraduates in particular is one of the best ways that we can shift the culture of STEM fields to be more inclusive and supportive of everyone. And Shirley was not convinced. And in fact, the thing I have learned from going to Harvey Mudd College is I get an enormous amount of credit and I've won a lot of awards for the stuff that our faculty and staff and students have done at Harvey Mudd. Let me just tell you for real, presidents do nothing. Well, actually, they ask for money. Sometimes they get money. They make some choices in terms of, who you appoint to positions and so on. But the most important thing a leader institution can do is enable the participants in that institution, which are really the faculty, staff, and students, alumni, members of the board of the corporation, so on and so forth, can get them inspired about doing something and then support them in enabling to do that. So that's what the College of Computing is all about. And I feel very lucky to be here to talk about something that I'm super passionate about, which is how do we teach computer science, data science, in a way that everybody can be engaged and supported. So everyone needs to learn. Everyone can learn. But our challenges are, and I'm going to say this at the end of my talk, but I'll say it now. We hold the keys to the future. I really mean that. We, as the people who are the leaders, both in creating the technology and in teaching the technology and in moving towards interdisciplinary collaboration between computer science and data science, mathematics, engineering, and other areas, we're the people who either make it possible for everyone to learn or not. So what do we need to do? We need to really think about the pedagogy, and I mean both face-to-face as well as hybrid and online technologies, the curriculum, and the culture that we put forward to enable everyone. And as everybody who is involved with any area of computer science education right now knows, we have an exponentially growing demand for access to this content. And we have to figure out how to meet that. So I'm not going to solve these problems, but I'm going to give you two hopefully compelling examples of efforts towards addressing a component of these problems. So I'm going to tell you about the BRAID project, which is a project for computer science departments that we've been working on for the last 4.5 years. And I'm going to tell you about Bridge to DSCS, which you can read as either Bridge to Data Science and Computer Science or Bridge between two disciplines. And the idea is to increase supply of faculty who really can teach computer science as both computer science for prospective computer science majors, but also teach computational techniques within their home discipline. So first of all, BRAID. So in the summer of 2014, I was giving a plenary at Snowbird, which is a conference put on every 2 years by the Computing Research Association. And the primary attendees are department chairs, or if you have a school or a college of computer science, deans. And my topic that I'd been asked to talk about was increasing diversity in computer science. Now, I talk about this a lot. It's because I care about it a lot, but it's also because my home institution has been remarkably successful in increasing participation of women in not just computer science, but also physics and engineering. And we have graduated for the last 2 years, our computer science majors that we graduated were more than 50% female. And we've done that in physics as well, and we've done that in engineering. Engineering tends to go back and forwards a bit between about 45% female to 55% female. And we're also, our computer science faculty is 50% female. And our faculty overall is 40% female. So we've done a lot for women, but we also have increasingly diverse students majoring in computer science, so African American and Latinx students, as well as Native Americans and others. So I was invited to give this talk, and before I started the talk, I realized that it wasn't a good idea just to talk about what had happened to Harvey Mudd. Because people can look at Harvey Mudd just as they can look at MIT, and they can say, oh, you're a really unique institution. In my case, they'll say, well, you have a female computer scientist who cares about diversity as a president. Or they will say, oh, you're recruiting the top students, undergraduate students in the country and from around the world. And of course you can do it there. They would say that about MIT as well, and so on. So instead of just talking about Mudd, I chose 6 universities and took a look at what they had done to encourage more women to major in their areas. So it will not surprise you that MIT and CMU were on that list as institutions that had very good numbers of women graduating in terms of the percentage of CS degrees. University of Washington, the University of British Columbia, large public universities, also on that list. Harvey Mudd. But the one that was probably most interesting is Cal Poly San Luis Obispo. And the reason Cal Poly is interesting is that they managed to get from 12% female in their CS major to 29% in 5 years. And they did that starting in 2008. Now, I think everyone here is old enough to remember what happened in 2008, 2009. We had a recession, and the funds for public institutions, state universities, were cut dramatically, including in California. So they did it at a time when, so they weren't a rich institution in the first place, but they did it at a time when it was particularly difficult in terms of resources. And I looked at what those 6 universities, take that back, 4 universities, 1 institute, 1 college had done. And I pulled out the commonalities. And as I'm giving my talk, I realized that I had a ton of department chairs, including several new department chairs, because one of the things that happens at Snowbird is there's a program for new department chairs. And so I said, towards the end of the talk, I said, the first 10 department chairs that say they want to try these things within their departments, I will help you raise money in order to do some of the things like sending your students to the Hopper Conference and the Tapia Conference. And when I finished my talk, there were 11 department chairs who had volunteered within 2 minutes of each other. And then a week later, I found the other 4 within that same period of time who were in my junk mail folder. But in any case, I ended up with 15, and those are the universities that you can see there. And they're hugely varying places. So UCI, UC Irvine, and University of Maryland, College Park, those are highly regarded CS departments. NJIT, University of North Texas, University of Nebraska at Lincoln, those are ones that are going to have University of Illinois at Chicago. Those are going to be places with a lot less resources. But anyhow, mostly public, a few privates, and I then set out to actually do something about raising the money that I had promised. And within 3 days, I had commitments from Microsoft, Google, and Facebook. And then I found the other 4 department chairs in my junk mail folder, and I then was able to get Intel to join the group. Now, one of the things that happened early on, Brad Smith, who's the president of Microsoft, and at the time I was on the Microsoft board, so Brad did not want Microsoft to be giving money to Harvey Mudd College to distribute because that would be a conflict of interest with my being a board member of a public company. So he said, Maria, why don't you partner with some other organization so we can give the money to the other organization, and they can distribute it, and then we won't have to put it on our conflict list. And the other thing he said is, since we're right at the beginning of this, why don't you find a researcher who would like to study what happens in these departments over, the period of this project? So I got on the phone. I got on the phone to Telly Whitney, who was the CEO of the Anita Borg Institute, and asked her if she'd like to do this, and she said yes. So they now have rebranded as AnitaB.org, but they became the partner. And I reached out to Jane Margolis, whom many of you will know from her work with Alan Fisher in studying why so few women were majoring computer science at CMU in the mid-90s. I reached out to Jane and said, are you interested in being the researcher? And she said, no, I've got way too much in my hands with Explore CS, which she was leading. She said, but there's this other person in my department at UCLA, Linda Sachs, and I think she'd be great. So the next day, I had a phone call with Linda. Now, I have, fortunately, had a lot of experience working with educational researchers. And the reason I say this is the first time I tried to do this, what's the right thing? Sometimes they are very suspicious of technologists who want to partner in research, because technologists don't have a clue about their methods. And fortunately, because I had 10 years of work doing this before, when I was on the phone with Linda, I was, able to have a great conversation with her. And it was clear when we started the phone call, she didn't think this was going to be something she wanted to do. And by the end of the phone call, she was going, yeah, this is great. So I claim entire success, not just for Linda and for her entire research team, who are leading the world in really trying to understand what attracts and supports people, women, people of color, and so on in computer science. They have been phenomenal. So the actions that I described and which the department chairs had to agree that they would take on were, 1, make your introductory course engaging and supportive for everyone. And I'll say a little bit in a moment about what that means. 2, build confidence and community among the members of your underrepresented groups. Do outreach to high school teachers and students. And for those institutions where it makes sense, i.e. is feasible, promote joint majors with disciplines such as biology and psychology. In other words, disciplines where there'll be a lot more women and people of color than computer science. Now, let me talk about making the intro course engaging and supportive. So one of the things we know from research is that both women and people of color are much more likely to be attracted to areas like computer science and engineering if you are demonstrating to them how what they are learning is actually important in solving the problems that face the world. When they see that they can use the knowledge and work on something that matters, it's just a lot more compelling. It's also the case that women and people of color are much less likely to feel a lack of confidence when they start an intro CS class. And if you have a couple of people in that course who, like I did when I was a young math major, want to answer every question and ask every question and dominate the airtime, that's extremely discouraging for people who feel like they don't know nearly as much, they don't have as much to offer. So there are all kinds of ways that you can change your classroom so that that doesn't happen. I mean, there's separating by section according to prior experience, prior knowledge in the discipline, because computer science is one of the areas where there's just a huge disparity. I mean, there are people who are starting at MIT or at Harvey Mudd who have almost the equivalent of a computer science undergraduate degree already in terms of just the amount of experience they've had. And there are people who have never written a line of code. And you put those two people in the same classroom, and it just is not fair, actually, to either of them. Another thing we do in the intro class is we make it very modular, because one of the things is, suppose I get the flu one week and I don't do well in that particular section of the course. If that's going to screw up my performance for the entire rest of the course, that is not a good thing. So trying to make it possible for, if you didn't particularly understand if-then-else statements or some other key idea about coding, it doesn't matter when you get to the next session. Oops. So what happened? Well, we managed to raise enough money so that we were able to give every department about, well, exactly $30,000 per year. Now, I would say the amount of work that departments actually did was more like a couple of $100,000 worth of work. But the thing that that $30,000 made a difference for were the things that it was not easy for them to do. So for example, departments routinely work on revising curriculum or, having a club for women in computer science or for people of color in computer science. What they don't have resources for is to send 25 students to the Tapia conference for people of color and people with disabilities, or to the Grace Hopper celebration, or to bring in perhaps speakers so they can have role models for their students to see. So they get $30,000 per year. It's pretty small. I mean, think about how far that would go at MIT. And remember, some of these departments like ASU, Arizona State University, they're humongous, okay? And in exchange, they participate in qualitative and quantitative research. And that's actually a pretty large commitment. So for example, we have been surveying the students in the intro course and then doing follow-up surveys with those students as they go on and we will continue probably that until those students actually graduate from college. It's a big commitment. They also, and I think this is probably one of the most important things in terms of the effectiveness of what has happened, is that the chairs commit to coming to a 2-day workshop. It's held at Harvey Mudd College every summer and sharing experiences. We have had participation from several of the 6 universities, institutes, and colleges that I mentioned at the beginning, being there as people who are helpful. We have also participants from some of our partner organizations, CRA, NC WIT, Commandit, and so on. We have every year about 8 universities that would love to be part of the project, so they're affiliates, so they don't actually get any money, but they come to the summit. So the big question, of course, is, did it make a difference? So one thing I should mention is every single department has seen a significant growth in CS enrollments. That's happening everywhere. But one of the things that we know in the past is that when we have had growth in enrollment, participation by women has declined. So if you see the growth in enrollment going up like this, then what happens is the growth of women goes down like that. So one of the things that I'm totally thrilled about is that after 4 years, and remember the first year of that 4 was mostly dedicated to getting things in place, like changing the intro class. So if we look at the growth, 14 out of 15 schools are like this, like they're really statistically significant, more growth in women than overall. 1 is pretty much right on the line. If we look at people of color, about half are above, about half are at or slightly below. One of the reasons, remember, these are very diverse institutions, and so we have some institutions that are in very white places. We have some institutions like UNT and UTEP that are already very significantly minority, and so it's less likely that we'd see growth there. So we now have an absolutely massive data set to be analyzed from all the data that's being collected. Our current initiative ends summer 2020, and the goal is that we hope that we'll actually expand to about 50 departments after we end this. Probably a slightly smaller financial contribution to each department, maybe 20K, because that means we literally would need to have on the order of $1 million a year to do this. But the thing we have demonstrated is that we have known for a very long time what departments needed to do to increase the participation of women and people of color, and it hasn't happened. And what we know now is if we engage the chairs, if we give them a small amount of money, and if we treat them as a cohort so they are informing each other, it works. Okay, very briefly, the postdoc program. So I think we all know that industry is hiring recent PhDs in computer science as well as existing computer science faculty members at salaries 2, 3, 4 times what academia can pay. And while some places who are very affluent, like perhaps MIT and Stanford, Princeton, might have a hope at competing, though actually I don't think it's really feasible given the whole structure of academic salaries overall, the vast majority of institutions can't compete. And it takes too long to take a student entering as an undergraduate to when they will get a PhD in computer science, and the demand from industry is basically infinite. So we're going to fix this. Somehow we need to find a way to provide people. So as Asu said, my PhD is in mathematics. I've got a tenure-track job at a math department. After I did my PhD, I hated it because I was teaching students who couldn't add fractions, advanced calculus. I went back after 1 year after my PhD to start a second PhD in computer science at the University of Toronto. They hired me as a faculty member at the end of 9 months. I had never written a line of code or read a computer science book before I went there. Believe me, I worked really hard. So the idea is there are tons of people who are getting PhDs in other areas of science and engineering who really want to be an academic, who are gifted at research and gifted at teaching. Let's give them that opportunity. Let's give them an opportunity to learn a little bit of computer science, but particularly how to teach computer science in inclusive ways. So we're going to start a postdoc at Mudd, hopefully in summer 2020. You might have seen summer 2020 before. So this is transitioning our energy towards this. And our goal is to prove that it works at Mudd, in particular prove that these people get good academic jobs. And then we're going to scale up to probably about 15 top computer science departments around the country. And we currently have an external advisory committee, which has people from MIT and Stanford and Northeastern and Northwestern and Princeton and Georgia Tech, and I could go on and on. And so this is our goal, to do this and really prove that you don't have to take 7 or 9 or 10 years to generate somebody who could be a huge asset to not just computer science, but through their home discipline as well. So, I already said that. Okay, call to action. We are the people who are controlling the future of the world. We are the people who will figure out whether or not learning approaches, pedagogy, culture, curriculum actually is accessible to everyone. And by everyone, I want to talk about people who are currently in some non-CS related job right now and haven't had math since high school, or maybe since the first year of college. We are the people who can take that on or not. We know that no single institution is going to solve this problem. It's one of the reasons I'm so happy that MIT is launching the College of Computing, because I think they're a very well-known flagship institution, and if they work on these things with the rest of us, that's going to be very helpful. We know that computer science will not solve this problem by itself. It's something that we actually have to do collectively. And we also know that academia cannot do it without help from industry and government. Thank you very much. Do we have time for questions?
Maybe one question.
Okay, one question.
There's a burning question.
Hi, Karen.
Really interesting, thanks. Are you doing longitudinal work, and are you looking into how much it's affected the confidence of these women students?
So the question is, are we doing longitudinal work? So yes, that's what Linda Sachs and her team is doing, and yes, they are looking at that issue. And explicitly, whether the approaches do affect their confidence, of whether that is correlated with their staying, because they're studying students who chose to major in computer science and also those who didn't after the intro course. And so that's one of the really key questions. And I know there's a lot more stuff to happen. It's fantastic to be here, and MIT, you have my very, very best wishes.